right, one more video here on scientific notation. The whole idea with scientific notation is it's just a really compact way to write numbers that are big or very small. So, for example, the company Google, the website, was actually just named after a number, and that number is really long. A Google, spelled slightly differently, is a 1, and then it has a lot of zeros. In fact, it has so many zeros, I'm not going to write them all. It has 100 zeros. So let's just pretend that there are 100 zeros there. Technically, I guess there would be like this. Okay. So there's 100 zeros after a Google. And that would take a long time to write out. And so scientific notation gives us a way to write that out a little bit more compactly. And it's all based on the fact that our numbers are powers of 10. So let me just review that first. That if we have 10 to the third power, 10 to the second power, 10 to the first power, 10 to the second power is 10 times 10, so that's 100. 10 to the third power is 10 times 10 times 10. It's 1,000. 10 to the first power is just 10. 10 to the 0 power is just 1. And our negative powers are just decimals, 1/10, 1/100th. That's just how our system works. So what I want you to notice is that the positive powers of 10 are the number of zeros. And the negative powers of 10 are also the number of zeros. Just that the positive powers are big numbers and the negative powers are little numbers. So if I have 100 zeros, then I know it's going to be 10 to the 100th power. And that's actually what a Google is. This is a lot easier to write than it is to write down 100 zeros all in a row. Let's take a look at a different number. Let's say I have a big number like 453720000, and I want to express this in scientific notation. The way we express this in scientific notation is we try to write a power of 10, and then in front of the power of 10, we try to write a number that's in between 1 and 10. We don't go bigger than 10, because then we could just bump the power up 1. And we don't go smaller than 1, because we could just bump the power down by 1. So what I'm going to do is I'm going to take the decimal where it was. The decimal was right there, because I was pretending it was a whole number. And I count 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 spaces, because there were 9 counts right there. And the number that I write in front of 10 is just all of the significant digits. And I write times 10 to the 9th. So when I look at this number, I know that it has 5 significant figures. And I know it has 10 to the 9th. So I know it's a really big number because of the 9. And I know the degree of precision, 5 significant figures. Scientific notation could also be used for really small numbers, like 0.0000307. Let's play the same game. We're just going to count in the other direction. 1, 2, 3, 4, 5, 6. I always want to put it after the first significant digit. So I will have 3.07 times 10. And I forgot what I counted. I think it was 6. 1, 2, 3, 4, 5, 6. But it's a negative 6 here because I had a really small decimal. And remember that the negative powers of 10 are the ones that are small numbers. The positive powers of 10 are the big numbers. So that's all you have to do for scientific notation, is you're just counting how many spots you know the decimal until the significant figures are all written down, and you put the decimal after the first significant figure, and then the exponent on 10 just tells you relatively how big or how small the numbers are. The nice thing about scientific notation is that you can use this to compare numbers a lot easier, like figuring out how many times bigger than something is, or how many times one thing would fit in the other, is a lot easier with scientific notation to get a rough estimate, because you can kind of round off the numbers. Like, for example, if you asked me, let's do this here. If you asked me how many times bigger the big number is than the small number, if I just looked at those numbers, man, that would be really hard to do by hand. Like to use long division or something to divide that huge number by that small number, that would be really annoying. So what I can do to get a rough estimate is to just use the scientific notation. So what I'm going to do is I'm going to round them off. This will round off to 5 times 10 to the ninth, and then this one would round off to 3 times 10 to the negative 6. So I just rounded the significant figures, but I kept the powers the same. Now if I want to know how many times bigger something is, I would divide it. So now I can just divide 5 times 10 to the ninth divided by 3 times 10 to the negative 6th. Let's see, 5 divided by 3 is like 1 2/3, so like 1.67. We'll just kind of round off here. And then remember, what do you do with exponents? Well, the exponent law says you go top power minus bottom power. So I get times 10 to the 15th. And then that's a good rough estimate of how many times bigger it is. It's a lot bigger because times 10 to the 15, remember, means I move that decimal 15 times to the right. So that's it. Please comment or ask questions if there's anything else I can do. And thank you for watching.